get a lot more money out of it. That's basically what we can do here. With that paint, the temperature goes down from 160 to 60 degrees. Now, continuing with the idea of insulation, but in the oil and gas industry. The oil and gas industry needs a lot of insulation for their pipes running across the desert. What you're seeing here is on the left, this is what you need to do. This is, we're just talking here about logistics, how to transport these materials from one location to the other. Power gel is a product. Now, the amount of packing material you need is 1/7 of how much you would actually need if you use traditional technology. This is all of this is cost, is direct cost. How many trucks you need to transport this material? You need 7 cars, 7 trucks to transport the current technology. You need 1 car if you have nanotechnology to transport the same amount of material. This is basically logistical advantages of using nanotechnology. If we go into the oil and gas itself, one of the biggest problems that we have in the industry is that we don't really understand how the oil well looks like. What is the temperatures? What are the pressures? What are the different phenomena taking place inside the well? And one of the best ways to do that is what is called, well, here we say sensing, but in the oil and gas industry they call it well illumination. زي تنور البيئة. It's not really to put lights on, but to actually be able to see what's going on. The problem is, the shell is not a hole like this full of oil. It's all about rocks, and the oil is absorbed inside the rocks. And you need to get that oil out. Nanotechnology enables us to use very small sensors, very small. It has wireless communication on it, has energy and has batteries on it, and it is smaller than the size of the core to get it out of the well. So this gives us the capability of actually solving these problems. I'm going to skip through some of these examples. Now, moving to construction industry. In Egypt, this is not in Egypt, this is in Italy. This is one of the very first buildings that was built using nanotechnology on it. What you're seeing on the left is it's actually a church, and the church is colored white. This picture was taken about 6 months ago. This church or this building has been in place since 2000. Almost 10 years, the color did not change. What you're seeing here on the left is a normal wall painted in white. And these are just normal water drops running down the wall. And as they run down the wall, because the material, the paint is treated with nanomaterials, it takes all the dirt. Can you imagine if we have this in Egypt? How our buildings will look like? The one time, well, of course here it rains a lot in Alexandria, but in Cairo, the one time it rains in Cairo, the whole city is washed. Do you guys understand this example, or are you not following? So basically, treating the wall, the color, the paint, with some nanomaterial that stop the building from the dirt sticking on the building. This is another example of a building that is also treated with the same material, and this is looking at 80 months span period, and you're looking at the change in the color. And as you can see on the top, there is almost no change in the color. So you build it once, you paint it, expected lifetimes is over 30 years. 30 years, the building is clean. Right? So this would be wonderful if we have something like this in Egypt. Some of these material has even better applications in them. Because if you use this material, you can actually have a photocatalytic reaction which actually destroys pollution in the air. So it is not only you're keeping the building clean, you can actually make the air cleaner around it. And this has been tested already in a lot of areas around the world, and you actually have 40% reduction in pollution. So a whole street painted with this material, you walk across the street, the air is 40% cleaner than normal air. There's applications for roads that I'm going to talk to you about this. This is in cement industry. What you see on the left, the bar, there is a test. Engineers, civil engineers can tell you there is the 1-day, the 7-day, and the 28-day test of compressive strengths for concrete or cement. What you can see is that nano-engineered cements in blue, after 1 day, you got almost triple the strengths. 7 days, triple the strengths. 28 days, you almost have double the strengths. This is just by engineering the normal Portland cements we have on the nano scale. We're not adding anything to it. Just engineering the size of the particle. This would allow you over 30% reduction in the amount of cement you are using. The same thing is done using steel. In blue, this is nano-engineered steel. You got 3 times the strength of normal steel, and it's even much more anti-corrosion, which would save us over 40% of the cost. Okay, now the next group is a little bit of a change into, some of you might be taking biomedical engineering. This is the contact lens that you see here. And the contact lens is loaded with nanoparticles that allow you to release medicine when you put the contact lens on your arm. Again, guys, these are not science fiction, by the way. These are actual products in the market. This is not just an idea. This is out there, it's being sold by different companies. What this does, this is specifically done for glaucoma. All people always face a problem with glaucoma. If I remember correctly. So what this does, it actually releases the medicine. As long as you're wearing the contact lens, it releases the medicine for glaucoma to treat your eye without actually having to take the medicine. The same technology is being used nowadays for diabetes. So people who are diabetic can actually detect that their sugar level is changing through this, and it would release insulin into the body. So it's not only about industry, but you can actually change the way we live our life. Now I'm going to give you some statistics and information from worldwide activities, and then I'm going to move into what's happening in the Middle East and what's happening specifically in Egypt in their technology. I told you that in 2007, the actual market size in green was $148 billion. The blue are trajectories that were put since 2000. As you can see, in 2007, we've exceeded the trajectories. In 2015, we are going to $3.1 trillion. What is happening in the Middle East in terms of spending? Saudi Arabia is putting over $6 billion into nanotechnology. Okay? $6 billion. United Arab Emirates has $75 million last year. Bahrain has about $150 million, $100 million in venture capital investments. Jordan has a national nano initiative, but we don't know what exactly they're doing and how much they're spending. Israel is spending over $200 million a year on nanotechnology in civil applications, so excluding military applications. In Egypt, we still do not have a dedicated fund for nanotechnology. But let me tell you something. Why is this important? Now, if you look at, we've done some statistics and we've looked at the amount of publications coming out from the Middle East. In red is Egypt. As you can see, from '96, Egypt was dominating the entire Arab world, the Middle East, with the exclusion of Israel. But in 2003, Iran is the blue bar right next to us. Iran started coming really strongly right next to us. In 2004, you can see they are coming very close to us. Now let's see what happens if we expanded this curve a little bit. To look from 96 to 2008, the same colors. What we've added here, we've added Israel in yellow. So Israel was dominating the Middle East. 2004, Egypt is still above Iran. Let's look at what happened in 2005.